You are an astronaut spiraling through the most colossal emptiness in existence, a realm where matter itself has surrendered, a territory devoid of stars, worlds, or swirling galaxies, a dominion where you wouldn't encounter another living being for hundreds upon hundreds of millions of light years in every conceivable direction. Yes, this incomprehensible expanse is known as the Boötes Void, or, as some astronomers have taken to calling it, the Great Nothing. And unless you somehow navigate back to your vessel, you'll be tumbling through the bewildering blackness of this enigmatic nothingness for eons beyond counting. Actually, your frozen, mummified remains would drift through this vastness for billions upon billions of years, because there's absolutely no one out here to come looking for you. And what's truly remarkable about this cosmic emptiness is that you've been gazing directly into it your entire life. That's right. Turn your eyes toward the northern celestial sphere and extend your arm between the asterism we call the Big Dipper and the brilliant red giant star Arcturus, which happens to be the fourth most luminous star visible in our night sky. Precisely there, at this very moment, you're staring straight into the abyss, the Boötes Void. The Boötes Void, nestled within the Boötes constellation. And from our vantage point on Earth, you can barely perceive it at all. But it exists, and you definitely don't want to find yourself trapped there. But that's precisely your destination. What would the experience be like to plunge into this unfathomable sea of darkness? Well, initially, it would require you a nearly unfathomable ocean of time just to arrive at its borders. The Boötes Void sits 700 million light-years distant from our blue planet, and I'm certain you understand. That's extraordinarily far. To provide some context, the Andromeda Galaxy represents our nearest major galactic neighbor, and that cosmic island resides 2.5 million light-years away from us. The Boötes Void exists 280 times more distant than that. So, even if you possessed the capability to travel at light speed, which the last time anyone verified, remains firmly in the realm of physical impossibility, it would consume 700 million years of your journey to reach it. But consider that this time frame roughly equals the entire span it's taken for animal life on our planet to evolve and diversify. From the most primitive early sponges clinging to ancient sea floors, to fish exploring primordial oceans, to reptiles claiming the land, to the reign of dinosaurs that dominated entire epochs, all the way forward through the emergence of mammals, primates, humanity, and ultimately to you, sitting here today reading these words. If you attempted using our present-day technology to accomplish this voyage, well, it transcends beyond mere impossibility into the realm of cosmic absurdity. Our swiftest spacecraft, the Parker Solar Probe, travels at approximately 0.05% of light speed. At that velocity, it would demand over 1 trillion years to traverse the distance to the void. Yes, an entire trillion years. Space possesses the capacity to completely shatter our comprehension. And even under these hypothetical circumstances, you couldn't actually ride aboard the Parker Solar Probe because it lacks any life support systems, comfortable seating, safety harnesses, or frankly anything designed for human occupancy. It's merely a scientific instrument. But let's engage our imagination and suppose that you could reach this destination traveling in a vessel with capabilities far exceeding anything we currently comprehend or possess. You understand, a proper hypothetical scenario. Right. So, you climb aboard your spacecraft and depart from Earth. But escaping Earth's gravitational influence is one challenge. Departing the entire solar system represents an entirely different magnitude of difficulty. You can't simply pilot your craft past Mars, beyond Jupiter and the other planetary bodies, until you reach the boundary of interstellar space. Absolutely not. Your spacecraft would require precise orbital mechanics. That's because, in order to permanently leave the solar system behind, you must break free from the sun's immense gravitational grip. Yes. So you're aware that Earth and every other planet in the solar system maintains an orbit around our parent star. Earth races through its orbital path at approximately 30 kilometers per second, which translates to roughly 18.6 miles per second. Your spacecraft would need to achieve velocities exceeding that tremendous speed to escape the gravitational bonds of the sun entirely. And you wouldn't simply accelerate in a straight trajectory out of the solar system. You'd have to execute your departure in a spiral pattern. To explain it in simpler terms, you'd need to complete several orbits around the sun, and with each successive orbit, your path would grow progressively wider and wider. No significant problem. You're piloting a super advanced, theoretically impossible spacecraft. You're absolutely capable of this. And as you venture increasingly further from our solar system, and eventually beyond the boundaries of the Milky Way, you'd begin to notice that the celestial canvas is growing progressively emptier. In the vicinity of Earth, our sky bursts with hundreds of millions of stars belonging to our Milky Way galaxy alone. But the instant you cross beyond our galaxy's borders, those familiar stars vanish from view. But you wouldn't have arrived at the void quite yet. The Milky Way extends 100,000 light-years from edge to edge, and Earth occupies a position right here, situated approximately halfway between the galactic center and its outermost boundary. If you could somehow travel at velocities approaching light speed and maintain a relatively straight trajectory toward the edge of our galaxy, it would still consume 26,000 years to fully leave it behind. Yes, even operating this hypothetical spacecraft with capabilities beyond our current understanding, it would still demand an extraordinarily long duration to reach the Boötes Void. And when you finally exit the Milky Way, as I mentioned previously, the stars disappear entirely from your view. At this point, you would begin observing fuzzy patches of luminosity scattered throughout the cosmos around you. Those represent distant galaxies existing millions of light years away. But before long, even those would fade from your visual range as well. Eventually, after millions upon millions of years of light-speed space travel, you'd cruise past the final star clusters like Ursa Major. That's the constellation that contains the Big Dipper asterism within it. Beyond that celestial landmark, there would be no additional galaxies ahead of you. The cosmic backdrop would transform into total blackness. The truly astounding aspect is that once you arrive at the very edge of the void, you'd still face an astronomical distance yet to traverse. Crossing the Boötes Void entirely, or even journeying to its central region, would constitute another impossibly lengthy haul. That's because the Boötes Void measures 330 million light-years in diameter. It represents the largest void structure in the entire observable universe. It's monumentally huge. Traveling at the speed of light, it would require 165 million years to journey from the outer edge to the central point. If you wanted to convert that down to kilometers or miles for perspective, it's approximately 1.5 quadrillion kilometers, or roughly 1 quadrillion miles. That's 1,000 trillion miles, just to reach the halfway point. That's the sheer magnitude of this void. And that's precisely why astronomers have dubbed it the Great Nothing. But let's imagine you resolved to attempt the crossing. Well, entering the void wouldn't resemble falling into some kind of pit or crater. There'd be no sudden descent or noticeable pull from gravity. It would simply be emptiness, extending in all directions. There's virtually no matter, scarcely any light whatsoever. By the time you reach the middle region of the Boötes Void, and you slip outside of your ship into the void itself, you'd be suspended in almost absolute darkness. With your naked human eyes, you wouldn't be capable of seeing a single star or galaxy in any direction you looked. The nearest galaxy would exist over 10 million light-years distant from your position. And even a relatively luminous galaxy at that staggering distance would appear far too faint for human vision to detect. To your perception, it would be pitch-black darkness surrounding you completely. If you've ever experienced cave diving in lightless underwater caverns, or floated in a sensory deprivation tank, well, you're beginning to grasp the atmosphere here. Except that instead of floating in warm, comfortable Epsom salt water, you'd be floating in an absolute absence of everything. Oh, and did I mention it's approximately 3 degrees Kelvin, or negative 270 degrees Celsius? That's negative 454 degrees Fahrenheit. It's as frigid as interstellar space can possibly become. Your spacesuit had better feature exceptional thermal insulation. Now, if you're curious, how did humanity even discover something that's essentially pure nothingness existing in space? Well, you'd need to travel back to the 1970s and early 1980s in the history of astronomy. That's when astronomers were engaged in an ambitious project to construct a three-dimensional map of the universe's structure. These dedicated astronomers were in the process of measuring how rapidly different galaxies moved away from Earth, applying the principles of redshift and cosmic expansion, when they stumbled upon a monstrous spherical gap existing in a region of space that could theoretically accommodate millions and billions of Milky Way-sized galaxies within its volume. That's peculiar. Empty space existing in the middle of space? Throughout the past few decades, scientists have progressively begun to understand how the universe is fundamentally structured, and it's probably not what you'd instinctively imagine. When you look upward into the sky, it might appear that there are trillions of stars distributed everywhere, spread out evenly across the cosmos, but the universe is actually formed from what astronomers call filaments. These are thread-like structures composed of stars and galaxies and galactic superclusters interconnected across vast distances. It's a massive cosmic web, or, as various scientists describe it, cosmic foam or quantum foam, where all the matter in the known universe groups together in elongated clumps and formations, while leaving bubbles and gaps scattered throughout the structure. The bubbles represent the voids. Now, why does the universe possess these void structures? Well, it's because of that universal force that maintains us rooted to the floor beneath our feet. Gravity. Yes, you see, since the universe originated in a superheated, super-energetic explosion that we refer to as the Big Bang, gravity has been relentlessly pulling the stars and planets and galaxies into these massive structures, spanning unimaginable distances. Scientists designate them as galactic walls and superclusters, and gravity has been pulling them toward each other since the beginning. Well, not literally forever, but since the moment the universe was born approximately 13.8 billion years ago. Over billions upon billions of years, these superclusters have grown denser and have continued pulling more and more material toward their centers of mass. The dense regions of space kept becoming denser, and the empty spaces kept becoming emptier through this ongoing process. That creates gaps between these clusters in the cosmic web or the cosmic foam structure, which admittedly sounds somewhat peculiar. The complete metaphor is somewhat tricky to follow if you're thinking about styrofoam. It might be easier to conceptualize it more like sea foam, or similar to soap foam that forms when you're washing dishes in your sink. When the sink fills up with soapy bubbles, and it appears to take up a substantial volume of space. But you realize it's really mostly just a squeeze of dish soap, and the remainder is simply air, creating the bubble structure. The universe operates kind of like that. It's all intricately interlinked, massive galaxy clusters pulled together by gravity with substantial amounts of dead air existing in between them. That dead air is scientifically designated as a void, and there are countless voids distributed out there throughout the cosmos. The scientists estimate that voids comprise approximately 80% of the universe's total volume. So yes, space is vast and vastly empty when you examine its actual structure. If you consider it carefully, it makes logical sense with all the immense light years of space existing in between galaxies and stars and planets throughout the observable universe. Well, you should certainly know, as you've been traveling through space for the past 700 million years at this point in our hypothetical journey. Out of all the void structures in the universe that astronomers have cataloged, the Boötes Void is the largest one we've ever discovered to date. So what would it genuinely be like to fall into the middle of that supervoid? Well, a void isn't comparable to a planet or a black hole with definable boundaries and gravitational characteristics. It's just empty space, extending in every direction. If you were dropped into the void from your high-speed spacecraft, or somehow tripped and tumbled into the void accidentally, you'd simply float in microgravity conditions, the same as you would anywhere else in deep space, far from massive objects. You wouldn't experience any sense of downward direction, because in a void, every direction is equally down. It would feel like an endless freefall that never concludes. But unlike in other areas of space where distant stars provide reference, without nearby stars or galaxies visible, you'd have absolutely zero reference points to orient yourself. You wouldn't even be capable of determining if you're moving through space or remaining stationary. In the Boötes Void, with nothing bright within sight, If your spaceship's batteries ran out of charge and killed the lights completely, you'd lose any remaining sense of direction and distance that you had left in your perception, because it's the ultimate void in every conceivable sense. It's the abyss incarnate, the quintessential chasm of nature itself. Maybe if your spacesuit featured hypersensitive, state-of-the-art instruments and detection systems, you might pick up a few faint glimmers in the far distance, such as the galaxies positioned on the edge of the void, or perhaps a few of the minor galaxies that do actually exist within the void's boundaries. Yes, because despite its intimidating name, the Great Void isn't completely and utterly empty. Researchers estimate that there are approximately 60 lonely galaxies floating around in there scattered across its vast expanse, and most of them are grouped together in a single filament that stretches through the central region of the void. Now, 60 galaxies might sound like a substantial number, but in a space of that tremendous magnitude, it's like searching for 60 goldfish in the entire Pacific Ocean. Your chances of ever bumping into one would be nearly zero statistically, and with your naked human eyes, all you would perceive is blackness, punctured by absolutely nothing, utter silence surrounding you, pure vacuum extending infinitely. Vantablack, in its most literal interpretation, the deepest possible black, if you've fallen into it, or become lost within it without any means of being able to determine where you are and which direction you're moving through space, you'd be stranded in there for eternity. It's just you and the emptiness of space in its most profound form. Maybe you'd go mad from the isolation and sensory deprivation. Or maybe if you had a suit that could sustain you indefinitely, it would be peaceful in a strange way. There'd be no one else around to bother you, nothing to collide into. You'd float there in the darkness, never knowing up from down, forever drifting in the greatest nothing in the universe that humanity has ever discovered. But let's take a step back and consider what we actually know about this mysterious region of space. The Boötes Void was first discovered in 1981 by Robert Kirshner and his colleagues while they were conducting a redshift survey of galaxies. They were systematically measuring how light from distant galaxies shifted toward the red end of the spectrum, which tells us how fast those galaxies are moving away from us due to the expansion of the universe. What they found was shocking. In a region of space where they expected to find approximately 2,000 galaxies based on the average density of the universe, they found almost nothing. Just a handful of galaxies scattered across this enormous volume. It was as if someone had scooped out a massive chunk of the universe and left behind only darkness. The discovery sent shockwaves through the astronomical community. How could such a massive empty region exist? What forces could create such a void? And, most importantly, what did this tell us about the structure and evolution of the universe itself? To understand the significance of the Boötes Void, you need to understand just how unusual it is. In most regions of the universe, galaxies are distributed relatively evenly when you look at large enough scales. Yes, they cluster together in groups and superclusters, but the overall density remains fairly consistent. The Boötes Void, however, has a density that's only about 10% of what we'd expect to find in a typical region of space. Think about that for a moment. If you carved out a sphere 330 million light-years across from a normal region of the universe, you'd expect to find thousands upon thousands of galaxies. Instead, the Boötes Void contains only about 60. It's as if 90% of the matter that should be there has simply vanished, or never formed in the first place. But here's where it gets even more interesting. The galaxies that do exist within the void aren't randomly scattered. As I mentioned earlier, most of them are arranged in a tube-like filament, running through the void. This suggests that even in this vast emptiness, gravity has been at work, pulling together what little matter exists into coherent structures. Scientists have proposed several theories to explain how the Boötes Void formed. The most widely accepted explanation relates back to the early universe and the tiny quantum fluctuations that existed just after the Big Bang. You see, the universe wasn't perfectly uniform when it began. There were tiny variations in density, some regions slightly denser than others, some regions slightly less dense. Over billions of years, gravity amplified these small differences. The denser regions pulled in more matter, becoming even denser. The less dense regions had their matter pulled away, becoming even emptier. It's a runaway process, The rich get richer, and the poor get poorer, cosmically speaking. The Boötes Void likely started as one of those slightly less dense regions in the early universe. As gravity worked its magic over billions of years, matter streamed out of this region toward the denser areas surrounding it. The galaxies and dark matter that would have formed here were instead pulled away to form the massive galactic walls and superclusters that border the void. But there's another factor at play here as well: the expansion of the universe itself. You see, the universe isn't just sitting still, it's expanding, and that expansion is accelerating due to a mysterious force we call dark energy. This expansion works against gravity on the largest scales, stretching space itself and making it harder for matter to pull together. In regions like the Boötes Void, where matter was already sparse, the expansion of the universe essentially locked in that emptiness. The few galaxies that did manage to form were separated by such vast distances that gravity couldn't pull them together effectively. Meanwhile, in the denser regions surrounding the void, gravity was strong enough to overcome the expansion and continue building massive structures. Now, you might be wondering, are there other voids out there? Absolutely. The Boötes Void is the largest we've discovered, but it's far from the only one. Astronomers have identified hundreds of cosmic voids throughout the observable universe. There's the Capricornus Void, the Sculptor Void, the Eridanus Supervoid, and many others. Each of these voids tells us something important about how structure formed in the universe. They're like fossils of the early universe, preserving information about the initial conditions that existed shortly after the Big Bang. By studying these voids, their sizes, their shapes, how they're distributed, astronomers can test their theories about cosmic evolution and the fundamental forces that shape our universe. Some voids are smaller than the Boötes Void, measuring only 50 or 100 million light-years across. Others are comparable in size, but the Boötes Void remains the champion, the largest known void in the observable universe. It's a testament to just how empty space can be, and how gravity sculpts the cosmos on the grandest scales imaginable. But let's return to your hypothetical journey into this void. Imagine you've now been floating in the darkness for what feels like an eternity. Your spaceship is somewhere behind you, or maybe ahead of you. It's impossible to tell. The darkness is absolute. The silence is deafening in its completeness. You might start to wonder about the nature of existence itself. Here you are, a tiny speck of consciousness floating in the largest empty space known to humanity. Every atom in your body was forged in the heart of a star billions of years ago. Those atoms came together through an impossibly unlikely series of events to create you, a being capable of contemplating your own existence. And now here you are, in a place where almost nothing exists. It's profound in a way that's hard to put into words. You are the universe experiencing itself, floating through a part of itself that contains almost nothing. It's like the universe looking into a mirror and seeing only darkness staring back. The psychological impact of being in such a place would be immense. Humans evolved in environments full of sensory input. Light, sound, texture, temperature variations. Our brains are wired to process constant streams of information from our surroundings. Remove all of that, and the mind starts to do strange things. Sensory deprivation experiments here on Earth have shown that people begin to hallucinate within hours of being deprived of external stimuli. The brain, desperate for input, starts creating its own. You might start seeing lights that aren't there, hearing sounds in the perfect silence, feeling sensations on your skin despite being in a vacuum-sealed suit. Some people describe a sensation of their consciousness expanding, a feeling connected to something larger than themselves. Others report feelings of intense fear and claustrophobia, despite being in the most open space imaginable. The human mind isn't designed for this level of emptiness. But let's say you somehow maintained your sanity. Let's say you had some way to measure time passing, some way to keep yourself grounded in reality. What would you observe as you drifted through the void? Well, not much, honestly. The void is remarkably stable. Unlike regions of space filled with stars and galaxies, where dramatic events occur regularly, supernovae exploding, black holes colliding, galaxies merging, the void is quiet, peaceful. Nothing much happens here. The few galaxies that do exist within the void are evolving slowly. Stars are born, live their lives, and die, but at a much slower rate than in denser regions of the universe. There's simply less gas and dust available to form new stars. Many of the galaxies in the void are likely older, redder galaxies, their star formation having slowed or stopped entirely. You might observe, if you had a powerful enough telescope, the gradual motion of these galaxies. They're not static, after all. They're moving through space, pulled by gravity toward the denser regions surrounding the void. Over millions and billions of years, some of these galaxies might eventually escape the void entirely, joining the galactic superclusters on the edges. But that process is incredibly slow. Galaxies move at hundreds of kilometers per second, which sounds fast until you consider the distances involved. It would take hundreds of millions, or even billions of years for a galaxy to cross from one side of the void to the other. And what about the void itself? Is it changing? Actually, yes. The void is growing. As the universe expands, the void expands along with it. The space between the few galaxies in the void is stretching, making the void even emptier than it already is. In the far future, billions of years from now, the Boötes Void will be even larger and even emptier than it is today. Eventually, in the unimaginably distant future, when the expansion of the universe has accelerated to the point where even galaxies within the same cluster can no longer stay together, the entire observable universe might look something like the Boötes Void does today. Dark, empty, cold. The heat death of the universe, as physicists call it. But that's trillions of years in the future. For now, the void remains a fascinating anomaly, a window into the large-scale structure of the cosmos and a reminder of just how empty space truly is. Let's consider one more aspect of your journey into the void: communication. If you're floating out there in the darkness and you want to send a message back home to Earth, how would that work? Well, radio waves travel at the speed of light, so any message you send would take 700 million years to reach Earth. And by the time it arrived, Earth would be a very different place, assuming it still exists at all. The Sun will have evolved into a red giant in about 5 billion years, likely consuming Earth in the process. But let's say you send the message anyway. Hello from the void. You transmit your words encoded in electromagnetic waves that begin their long journey across the cosmos. Those waves spread out in all directions, growing weaker as they travel, diluted by the inverse square law. By the time your message crosses the void and reaches the galaxies on the other side, it would be incredibly faint. Any civilization trying to receive it would need extraordinarily sensitive equipment to detect it against the background noise of the universe. And that's assuming they're even listening, and that they're looking in the right direction, and that they have technology capable of decoding your message. The odds of your message ever being received are astronomically small. You'd be shouting into the void, in the most literal sense possible, with almost no hope of ever being heard. And so there you have it. The Boötes Void, the Great Nothing, the largest empty space in the known universe, a place where darkness reigns supreme, where matter is sparse, where silence is absolute, a place that reminds us of the true scale of the cosmos and our own insignificance within it, but also a place that demonstrates the incredible power of human curiosity. We discovered this void not by traveling there, but by carefully observing the universe from our tiny planet, measuring the light from distant galaxies, piecing together the three-dimensional structure of the cosmos. It's a testament to the power of science and human ingenuity. You know, there are so many incredible places in the universe to explore, so many mysteries still waiting to be unraveled. Our solar system alone contains wonders we've barely begun to investigate. We've sent robotic probes to Mars and Venus, but humans have never set foot on those worlds. We've only glimpsed Pluto from a distance. The moons of Jupiter and Saturn likely harbor oceans beneath their icy surfaces, possibly even life. And beyond our solar system, there are billions upon billions of other stars, many with their own planets. Some of those planets might be Earth-like, with liquid water and atmospheres capable of supporting life. The search for extraterrestrial life is one of the greatest scientific endeavors of our time. But the void reminds us that the universe is not just about what's there, it's also about what's not there. The emptiness is just as important as the fullness in understanding how the cosmos is structured and how it evolved. The voids and the filaments, the darkness and the light, They're two sides of the same cosmic coin. So while falling into the Boötes Void would certainly be a memorable experience, one of absolute darkness and isolation, it would also be a journey to one of the most scientifically significant regions of the universe, a place that holds clues about the origin and fate of everything that exists. And maybe, just maybe, floating there in that darkness, you'd gain a unique perspective on existence itself, a understanding that emptiness and fullness are both essential parts of the cosmic tapestry. That sometimes, nothing can be just as meaningful as something. But let's be honest, you'd probably rather stay home on Earth, where the sky is full of stars, where you can feel the ground beneath your feet, where you're surrounded by life and light and warmth. The void is fascinating to study from a distance, but it's not a place any sane person would want to visit. Still, it's out there, waiting in the darkness. The Great Nothing, the Boötes Void, a monument to emptiness on the grandest scale imaginable. And every time you look up at the northern sky, between the Big Dipper and Arcturus, you're looking directly at it. You're staring into the abyss, and the abyss, as they say, stares back. Only in this case, the abyss has nothing to stare back with, because there's nothing there. Just darkness, just emptiness, just the void.